Okay, a vector can be represented in terms of its components, and the number of components depend on the plane or space in which it is drawn. For example, if it is drawn in two-dimensional plane x and y, it will have two components, and if it is drawn in three-dimensional plane, three-dimensional space x, y, z, it will have three components. Now let us consider vector A as on your screen. It is drawn in two-dimensional plane xy, and it makes an angle theta with the x-axis, which is its direction. In order to find out its component along x-axis, we simply draw a perpendicular from the head of vector A onto x-axis like this, and the x component will be from origin until this perpendicular. This red vector is the component of A along x-axis. It is represented with ax and called x component. Similarly, we draw a perpendicular from the head of vector A onto the y-axis to find out y component of this vector like this, and from origin until this perpendicular will be y component of vector A, which is represented as A subscript y and called as y component. Both of these components ax and ay make a right angle with each other, or means the angle between them is 90 degrees. That's why they are also called as rectangular components. Now ax is equal to a cos of theta, and ay is equal to a sine of theta. In this, a is the magnitude of vector A and theta is the angle that it makes with x-axis. So these are derived from trigonometric ratios. Now if we move component A y on the head of component ax like this, you will realize that it is as though ax and ay are added through head to tail rule, and a vector A is the resultant vector of ax and ay. Therefore, we can write like this, that A vector is equal to the sum of its components. If there were three components, like if there was x-axis, y-axis and z-axis, then there should have been another component az, which would have been along z-axis. Then our vector A would be represented as ax plus ay plus az. Okay, now if you look carefully, it makes a right angle triangle like this, right? So if there is a right angle triangle, we can use Pythagoras theorem, right? By using Pythagoras theorem, we can find out the magnitude of vector A by adding the squares of ax and ay. Ax is the base and ay is the perpendicular, and the square root of that. So I hope you are familiar with Pythagoras theorem. So by using Pythagoras theorem, we can find out magnitude of vector A, right? So a vector has two things, a magnitude and a direction. So how can we determine direction? Using trigonometric ratios, we know that tangent theta is equal to ay over ax. So tan theta is equal to ay over ax, where ay is perpendicular and ax is base, right? So by trigonometric ratios, tangent theta is equal to perpendicular over base. Then since theta actually represents direction of the vector, so we can rearrange these terms like this, and theta is equal to tangent inverse ay over ax. So that's how we find out direction of vector A. So these are the formulas that you need to remember. This is how we determine the magnitude and direction of a vector from its components. Okay, now next is unit vectors. So by name, unit means one, right? So unit vector means a vector that has something which is one. So one can be magnitude, right? So unit vectors are the vectors which has a magnitude that is exactly equal to one, but it does not, they means unit vectors do not have any dimension or any units, right? So they are merely used to represent directions. Okay, so that's why they have unit magnitude, means they do not, if they are multiplied with any vector, they do not change anything because they are unit, and their direction is along a certain axis. For example, in this case we have three dimensions, x, y, and z. So a unit vector which is along x, that is this one, and the representation is a little bit different. The unit vector is represented with a hat on the top instead of an arrow. So a normal vector is represented with an arrowhead, sorry, with an overhead arrow, while the unit vector is represented with a hat. Okay, so conventionally, a unit vector along x-axis is represented as I hat. Okay, and the unit vector along y-axis is represented with j hat, and a unit vector along z-axis is represented with k hat. Okay, so these are the unit vectors which are well known, are like standard in nature. So I hat will always represent x, j hat will always represent the direction of y, and k hat will always represent the direction of z. Now if we draw a vector in this space, x, y, z space, that vector will have three components. Like this is a vector a, this vector will have three components: ax, that will be along x-axis, ay, that will be along y-axis, and az, that will be along z-axis. And it will be represented like this. A will be equal to, you saw in the previous slide that a vector can be represented as the sum of its components, right? So here ax can be represented as ax plus ay plus az, right? So in this case, in this example, you will notice that there are no overhead arrows on ax, ay, or az. The reason is, here ax is the magnitude of x component, ay is the magnitude of y component, and az is the magnitude of z components, and their direction is represented with I, j, and k. Means this magnitude along x-axis, this magnitude along y-axis, and this magnitude along z-axis. Okay, so these are the unit vectors are used to represent direction of a vector. So these are some key points about unit vectors. It is a vector that has magnitude of exactly 1 and points in a certain direction, so it lacks both dimension and unit. They are merely used to represent directions. And then unit vectors are represented with a hat instead of an overhead arrow. And unit vectors in positive directions, means positive directions of x, y, and z, are represented as I hat, j hat, and k hat respectively, that you have just seen in the previous slide. Okay, now let's look at how we can add vectors using their components. So the previous method that we studied, head to tail rule, was a graphical method. You need to actually draw according to the scale vectors on your notebooks. But if this method is not graphical, we just need to find out components, and then we use them to find out sum of two or more vectors. So let us consider we have a vector r that is sum of vectors a and b, and vectors a and b can be represented like this. They are in space, for example, or in a plane. So if they're in a plane like x and y plane, so it will a will be equal to axi plus ayj. But if there is z also, then we'll add a zk. Okay, so similar is the case with b. B will be represented as sum of bxi and byj. If there is a z-axis, then we can add bzk also. So r being the uh, resultant vector of a and b can be represented like this. R is equal to vector a plus vector b. So since r is also a vector, it will have components rx, ry, and if there is a z1, then rz. So each component of this vector will be equal to the sum of the components of these two vectors. For example, x component of rx will be equal to the sum of x components of a and b vectors. Similarly, the y component of r will be equal to the sum of y components of a and b. And if r has a z component, then it will be equal to the z components of a and b. Then we can represent our resultant vector r like this: rxi plus ryj and rzk, like all other normal vectors. But here rx is equal to ax plus bx, this one, and ry is equal to ay plus by, and rz sorry, and rz is equal to az plus bz. Again, its direction can be found out using this formula tangent theta that you saw in previous slides, that tangent theta is equal to the perpendicular components ry over rx. Okay, now how can we find out magnitude of it? To find out magnitude, we will use this equation, that r will be equal to the square root of the sum of the squares of its components. If there are two components, then rx plus ry. If it has three components, r square plus ry square, rx square plus ry square plus rz square, and square root. And the direction is so easy: theta is equal to tangent inverse component y divided by component x. So that's how we can do vector addition using the components. So this is a vector addition by components method. So these are the two methods which we can use depending on the type of data we have, or for adding two or more vectors.